Hello everyone. In this video we will solve exercise 2 about general functions. Part 1, calculate the limit of f at plus infinity. Now we start by substituting plus infinity. So the limit of f of x as x tends to plus infinity is 3 minus 2 radical infinity over 3 plus 2 radical infinity, which is infinity over infinity indeterminate form. Now how will you solve this? The limit of f of x as x tends to plus infinity, in fact it's the limit of minus 2 radical x over 2 radical x. Okay, let's interpret more. Take radical x as a common factor, so you will get 3 over radical x minus 2. Radical x as common factor, you will get 3 over radical x plus 2. Now radical x with radical x is not equal to 0. 3 radical x tends to 0, 3 radical x tends to 0, so it is negative 2 over 2, which is minus 1. This means that the function will have a horizontal asymptote y equals negative 1 at plus infinity. Show that f is strictly decreasing over r and set up the table of variation of f. Now in order to show that a function is strictly decreasing or strictly increasing, you need to calculate f prime of x. If f prime of x is negative, this means that the function is decreasing. If f prime of x is positive, this means that the function is increasing. Now here you have the function is ratio of two irrational functions. The ratio, derivative of the ratio is numerator prime, the derivative of the numerator multiplied by the denominator, minus the derivative of the denominator multiplied by the numerator over denominator power 2. Now before we continue, let's calculate the derivative of radical x. So radical x prime, which is x, radical means x power half, x power half prime. Now you have x power n prime, which is n, x n minus 1, so it is 1 over 2 radical x. Back to our derivative. 3 minus 2 radical x prime is the derivative of minus 2 radical x. So it is minus 2 times 1 over 2 radical x times 3 plus 2 radical x minus also the derivative of 2 radical x, which is 2 times 1 over 2 radical x into 3 minus 2 radical x. This is because the derivative of 3 is 0. And this is the sum of two functions. So 0 minus the derivative of 2 radical x. And here the same, 0 plus the derivative of 2 radical x over 3 plus 2 radical x squared. This is minus 1 over radical x times 3. So minus 3 over radical x minus 2. This is minus 3 over radical x plus 2. 2 radical x with 2 radical x, you will have 2. 1 over radical x times 3 is 3 over radical x over 3 plus 2 radical x power 2, which is negative 2 with positive 2, minus 6 over radical x over 3 plus 2 radical x squared. Now radical x is positive, 6 is positive, 3 plus 2 radical x squared is positive. So minus 6 over radical x over 3 plus 2 radical x squared is less than 0 strictly. So the function is strictly decreasing. This function cannot be equal to 0. You have minus 6 over radical x. It can be written like this. Minus 6 over radical x, 3 plus 2 radical x squared, so cannot be equal to 0, which means that the function is strictly decreasing because the derivative is strictly less than 0. Now for the table of variation of f of x. So table of variation, we have f of x is 3 minus 2 radical x over 3 plus 2 radical x. F of x is strictly decreasing as x tends to plus infinity. F of x tends to negative 1. Now the domain of f is 0 plus infinity. Now f of 0, let's find f of 0. F of 0 is equal to 3 minus 0 over 3 plus 0, so 3 over 3 is equal to 1. So this is the table of variation. X, f prime of x, f of x. At 0, f of x is 1. At positive infinity, f of x is negative 1. F prime of x is negative, so f of x decreases from 1 to negative 1. Verify that the straight line D with equation y equals x meets c at a unique point with abscissa between 0.4 and 0.5. In order to solve such problem, you need to solve the equation f of x equals x in order to find the point of intersection. So 3 minus 2 radical x over 3 plus 2 radical x equals to x. Now this equation is hard to solve, so let's study g of x, which is f of x minus x. We will check g of 0.4, which is f of 0.4 minus 0.4. It's almost 0.07 greater than 0. Now we will find g of 0.5. G of 0.5 is f of 0.5 minus 0.5, which is about negative 0.03. Now since the function changes sign between 0.4 and 0.5, so g changes sign. So f of x minus x changes sign between 0.4 and 0.5. This means that you have a solution alpha, so there exists alpha, where alpha is between 0.4 and 0.5, where g of alpha is 0, so f of alpha equals alpha, So f of x intersects y equals x at point with abscissa alpha. Now as for the uniqueness, since f of x is decreasing, so f of x is decreasing, and y equals x is increasing. This means that the function g of x will have a unique solution. So the curve meets the line y equals x at a unique point with abscissa alpha, where alpha is between 0.4 and 0.5. Solve f of x equals 0, then trace c. Now let's solve f of x equals 0. F of x equals 0 means 3 minus 2 radical x over 3 plus 2 radical x is equal to 0. The numerator is 0. So 2 radical x is equal to 3. Radical x is 3 over 2. So x is 9 over 4, which is 2.5. Means that c passes through the point 2.50. Now we know from previous parts that c starts at the point 0, 1 and have y equals -1 as horizontal asymptote. So it will start at the point 0, 1, passing through 2.50 and then having y equals -1 as horizontal asymptote. So this is the graph of fc. Verify that over 0 plus infinity f admits an inverse function f minus 1 whose domain of definition to be determined. Now for a function to have an inverse, so for f to have an inverse, it should be continuous and monotonic, so strictly increasing or decreasing. So monotonic. Let's check those two conditions. One is f monotonic. F of x is equal to 3 minus 2 radical x over 3 plus 2 radical x. Now 3 plus 2 radical x, it seems you seem to have a problem in the denominator, but no, since 3 plus 2 radical x is never 0. So 3 plus 2 radical x is positive. Since 3 is positive, 2 is positive, and radical x is positive. So f of x has no problem, no discontinuity. So f of x is continuous. We have proved previously that f of x is strictly decreasing, so means monotonic, which means that f has an inverse function f minus 1. Now, as for the domain of f minus 1, now the domain of f is 0 plus infinity. We have f of 0 is equal to 1, and as x tends to plus infinity, f of x equals negative 1. Now here, since the function is decreasing, the domain will be reversed. So d of f minus 1 will be equal to f minus 1 of plus infinity, f minus 1 of 0. So the domain is equal to negative 1, 1. Part 6b, solve the equation f minus 1 of x minus f of x equals to 0. F minus 1 of x minus f of x is 0 means f minus 1 of x is equal f of x. This means that when f minus 1 of x and f of x intersect. Now we know that f minus 1 of x and f of x intersect only at their axis of symmetry, which is y equals to x. So f minus 1 of x equals f of x means that when f of x equals x. This is solved in part 4. When f of x equals x, then x will equal to alpha. So f minus 1 of x minus f of x equals 0, equivalent to x is equal to alpha, which is between 0.4 and 0.5.